again, super tight, Mr. Jenkin gets the question up on the smartboard. And the question is number 13 from the Chapter 8 test review, car commercials. A car dealer investigated the association between the number of TV commercials he ran each week and the number of cars he sold the following weekend. He found the correlation to be R is equal to, R is equal to 0.56. During the time he collected the data, he ran an average, keyword right there, average of 12.4 commercials. That suggests a mean with a standard deviation of 1.8. And he sold an average, there we go, mean again, of 30.5 cars with a standard deviation of 4.2. So next weekend he's planning a sale, hoping to sell 40 cars. Create a linear model to estimate the number of commercials he should run this week. So probably the hardest part about this problem for me was when I'm thinking about it logically, I drew my picture and I thought, well, I think the number of commercials that you run is going to be the explanatory variable, and the number of cars you sell is going to be the response variable. That's kind of what makes sense to me, is that if I run a bunch of commercials, then I sell a certain number of cars. And so when I was working this problem, initially I got the wrong answer, and I sent an email to David Bach, the author of the book. I said, what gives? And he says, read the problem. Because the problem says, and it does in fact, say, estimate the number of commercials. So what we want to predict is the number of commercials. And if we're going to predict the number of commercials, then that has to be our y-axis. And as counterintuitive as it sounds, cars sold has to be our x-axis. So once I got that clear, then the problem kind of fell into place, because what I did was I thought, well, let's think back to the last quiz and let's set this problem up just that same way. So if you remember, well, first of all, what we're going to end up needing, as you can see, if we're going to estimate the number of commercials, is we're going to end up needing the formula. We're going to need a regression analysis. We're going to need a formula here to be able to make that prediction. So if you remember the last quiz, we would have x bar, our average of x, and our standard deviation for x. And then we'd have our y bar, our average for y, and our standard deviation for y. And then we'd have our r, and then we could put together our y hat formula. Let's see if we can move this down a little bit, hope I don't mess it up. And I'm not necessarily going to be able to, but let's try. Okay, there. Extend the page, please. Sorry for wasting your time on this, but I want you to be able to read it. And let's go just these two, and we'll move them back up here into our orientation. Okay, so now I'm going to make proper labels for this. Well, my x is my number of cars. So my x bar, I'm going to call that cars bar. And my standard deviation of x is my s cars. My y bar is my commercials average. My sy is my standard deviation of commercials. My r is my r, and my y hat is what I'm trying to get. I'm trying to get my formula right there. Well, they've given me the information that I need. So my average cars sold, the average cars sold was 30.5. So that goes here, 30.5. And my standard deviation for cars sold was 4.2. My average commercials were 12.4. And my standard deviation for commercials was 1.8. And my R they gave me was 0.56. Well, now I'm just flying, because now I'm going to be able to make some calculations. The first thing I need to calculate my formula, remember my formula is y hat equals b sub 0 plus b1 times x. So again, let's write that into the form that we want. I think I'll get rid of this little diagram now that we've got that pretty clear. We'll beat it out of the way. Okay. So first thing I want to do is I want to calculate the slope. Slope is equal to r times sy over sx. Well, I made a little chart up here, which for just this reason. My sy is 1.8. My sx is 4.2. And I need to multiply the top by my r. So I'm going to do that. And I'm going to go 0.56. So what's my slope going to be? Let's see if you can call the calculator and get an answer for us. Let's clear that out. I said let's clear that out. Okay. So I'm going to go 0.56 times 1.8, enter. I get that. And I'm going to divide it by 4.2, enter. Ah, wonderful. I get a good slope. I get a slope of 0.24. Part of my equation is now solved. I know what my b sub 1 is. When I know what my b sub 1 is, how am I going to find out my b sub 0? Ah, I have average of cars and I have average of commercials. Well, the commercials is my y, so my average commercials is 12.4. That's equal to 12.4. B sub 0 plus 0.24, that's my slope, times the number of my average for cars, which is 30.5. So let's see if I can figure out now what B sub 0 is. Well, let's do the math. I'm going to have, I can't see it very well, huh? What is it? 12.4. Okay. So I'm going to have 0.24 times 30.5. So that gave me, these two things here are equal to 7.32. And if I subtract that from both sides of the equation, then I'm going to get 12.4 minus 7.32. And I get my b sub 0. B sub 0 is equal to 5.08. Well, now, if I'm not mistaken, I should have a complete formula. I have commercials hat is equal to 5.08 plus 0.24 cars. What they told me way back at the top here in my original question is that I want to estimate the number of commercials, that he should run. And I've been told that I need to have, that I'm trying to solve this for 40 cars. Remember that up there again? It said he wants to sell 40 cars. Right here it says 40 cars. So this should be pretty simple. I should be able to just plug 40 in for cars. So I'm going to get commercial hat is equal to 5.08 plus 0.24 times 40. What does that give us as an answer? 0.24 times 40, enter, plus 5.08, enter. I get 14.68, number of commercials is 14.68, and since we can't run 0.68 of a commercial, I would round that up. He needs to run 15 commercials to be able to make the sales that he wants to sell. Or he's going to run 15 commercials based on selling 40 cars.